Okay, so let's talk about IP basic. Our main topic, right? Today's main topic is IPv4 address, and this is the typically the IP header uses IP addresses, source and destination IP address, right? So there are many different fields in IP header, but two most important fields are source and destination IP addresses. And each IP address is 32-bit long, right? 32-bit. So example of the IP address is, for example, is this 169.199.69.137. And this is IP address, right? This is 32-bit long. And it's typically, this is like represented in binary form, and this is like machine readable, right? But humans, right? We are not. We are really good at a decimal number, and this 32-bit number, right? That this binary bit can be divided into 4 different chunks, and each chunk is called either byte or the octet. And you know the octopus has 8 legs, right? An octet has 8 bits, and there's like 1 byte, right? 1 byte is equal to 8 bits. So the 32-bit IP address has what? 4 octets, right? The first octet, second, and third, and the fourth octets. And it's like 100101001, right? This first octet. If we convert this binary bit to decimal number, it's 169. And etc. So we have, typically this is what we use, right? When you configure your laptop or desktop or your tablet, this is the form, right? This is like decimal number. The IP address expressed in decimal number are the ones that we typically use, right? So let's talk about the IP header a little bit more, right? Let's say you have a machine, your laptop or a tablet PC, right? Let's say you have a machine, right? And the IP address of this machine is, just for the simplicity, let's say 1.1.1.1, right? And in order for a machine or the workstation or any device to communicate with another device over the internet, over the network, each device must have an IP address. So let's say this is you, right? This is you, right? And then you want to send a message to your friends, and your friends using another machine or the tablet or workstation or whatever. Your friend's machine, right, must have what? IP address. So let's say this is IP. This machine has a IP address of, let's say 2.2.2.2, right? So this machine will send a packet, right? Let's say this is like email or the letter, whatever. So in the email it said, right? So this is like a message, and typically it has what? In this message there is IP header, right? And then there's TCP header, right? And then there's a message. Let's say the message is I love flowers or whatever, right? So there's some message. And inside this IP header, right, as I show you in the previous slide, IP header has many fields, like a time to leave, and let's see what other fields it has. Flag, type of service, and packet length, and protocol. Typically the protocol is IP, right? But there are 2 most important fields in IP header, as I said, is source and destination IP address, right? So if you look at this IP header, it has a source IP, the source IP address, right? And then destination IP address. Destination IP address. And the source IP address in this case is 1.1.1.1. and the destination IP address is 2.2.2.2, right? The good analogy is when you write a letter to, let's say to your mom, right? If you look at your envelope, right? Let's say this is envelope, you have what? From, right? And then you have to. Let's say from, it's, let's say you, right? Kevin, right? And then to, it's you have a Kevin, and then there's an address, right? California, right? And then to is, let's say your mom, and then your name of your mom, and what? If your mom lives in, let's say New York, is NY, and their zip code, right? So the source IP address you can think is like a from, right? And then this destination address you can think as a to field. Okay. And okay, so this is the example of IP address. And another thing is, since IP address, right? Let's say look at each IP address, like the IP address, right? And let's say the IP address is, I said, 32-bit long, right? And it has a 4 chunk, right? And each of them, it's like, this is like, each of them is called octet, right? This is first octet, and this is second and third and fourth. In each octet, we know that it's 8 bits, right? 1 0 1 1 0 0 1 1 2 3. Okay, 0. So this is like, since this is 8-bit, right? If you convert into the decimal number, this decimal number, the range of this decimal number is anywhere from 0 to what? 255, right? Because it's 8 bits, so the maximum number for is like 1111 1111, right? If you convert this 8 bits into decimal number, it's a 255. So the range of this the octet, right? If you convert into decimal, it's anywhere from what? 0 to 255. So this is a mean and this is max, right? So for example, you can have theoretically, you can have a 255.255.255.255, right? Okay. But you never can have, let's say, 210.276.19.1, right? You never can have any number above 255. So this is not a valid IP address. Okay. Having said that, IP address is in a sense that it's a hierarchical. Okay. So what do you mean by hierarchical? So it has network address and host portions, right? The network portion and host portion. And as you can see, so in that way, it's network and it's a hierarchical, right? It has network and host portion. And okay, so today we assume that every IP address is classful, right? It's not later, we should say. Okay, and then this classless IP address we'll talk about in a subsequent lecture, but today's basically we assume that all the IP addresses are classful, and this is old technology, right? It means that value of the first octet determines the network portions and the host portion. So this is a key. And when the IP address is classful, right? Okay, so there are three. Okay, so let's just skip the first 3 slides. And then I said the IP address is hierarchical, right? And you have to know which there's another concept called subnet mask. The subnet mask really tells you which portion is really belong to network and which portion is really belong to the host. And the subnet mask basically is a 32-bit long, right? and it's a contiguous set of ones followed by a contiguous set of 0. So example of the subnet mask is like this. 1, 1, 1, 1, right? Contiguous set of ones followed by what? Contiguous set of 0. Okay? So that's the one good example of subnet mask, right? And the subnet mask is expressed as a dotted decimal. For example, 255.255.00, or you can say /16. So it's /16 because what? Since it has what? How many number of ones? It has 16 number of ones, right? So that's why either we can use this notation, decimal notation, dotted decimal notation, or you can use a prefix notation, /16. Okay? So let's just go back to this previous slide, right? You know, the IP address has a two-part, network portions and host number. So I'll talk a little bit more about this later, but the basic concept, right? The basic concept is this. So you know the network address, right? Let's say this is your network address, I mean the IP address, right? And then somewhere in the middle, we can draw the line. And you know the left side is what? Is network portions. And then right side is what? Host portion, right? And then so this is IP address. And the line, right? This boundary, right, is determined by something called what? Subnet mask. So let's say the subnet mask is, I said, is a contiguous set of ones, right? 1, 1, 1, 1, 1, 1, 1, 1, right? 1, right? And then it's what? Contiguous set of 0, right? 0, 0, 0, 0. It's contiguous set of zeros. So you can draw the line here, right? So this is where all the ones here, right? So this is really like network portions, right? And this is what? The host portion, right? So the main role, right, of the subnet mask is what? It really tells where we can draw the line, this boundary. So the left side is what? Is network portions, and right side is host portions. So that's the main role of the subnet mask, right? Okay. So and another good analogy, right, of this example, right? This, let's say IP address is hierarchical, is you can think network address. So when you have a building, right? Let's say Jack Brown building. So we have we have Jack Brown building, right? In Jack Brown building, so this is JB. There's a lot of classrooms, right, or offices, right? So let's say we have like room 124, and this is what room let's say 26, and etc. Right? And then there's a fifth floor. There's a room there's an office. There are many offices. Let's say this is room 554, and there's another rooms, etc. Right? You can think network address in this analogy, right? You can think network portion is what? Jack Brown building, JB, right? And you can think the host portion, right? You can think the host portion as what? Host portion as, let's say, room number. So example of the host portion is, let's say, room what? 124, right? So in essence, right, the labeling, right, is hierarchical, because we typically say what? Jack Brown what? Room 124, right? To locate this. And this one, right, we'll say Jack Brown, right? So this network portion, Jack Brown, right? Room 554, right? So this is a good analogy, okay? And let's just go back to our lecture slide. Okay, so now there are 3 different types of addresses. Okay, so I'll talk about this in the next lecture. Okay, so let me just stop here.